Alright, now the next operation that we want to be working towards is matrix multiplication. But before we get into multiplying two matrices together, let's consider multiplying a matrix by a scalar, so a constant. So if I would like to multiply a matrix by 3, as I have in this example, then we do that simply by multiplying each entry in the matrix by 3. So this would be 3 times 0. Entry row 1, column 2 would be 3 times negative 4. Row 1, column 3, we'd have 3 times negative 2, and we continue this for the bottom row as well, multiplying each entry by 3. This is called multiplying by a scalar because you're just scaling everything in the matrix by the same factor. So we would have 0, negative 12, negative 6, 9, negative 3, and 18. And this would be the matrix 3 times the original matrix. Now scalar multiplication is pretty simple. You just scale everything by the same factor. Now let's start to develop matrix multiplication, so multiplying two matrices by each other. Before we can look at matrix multiplication, we have to look at a simpler version called the dot product. The dot product is where you multiply a single row matrix, so a matrix that has one row, by a matrix that consists of one column. Now, in order to do multiplication for matrices, the size of the matrices are going to have to match up in certain ways. And so the dot product is only going to work if you have a 1 by n matrix, so this row matrix is 1 by n, and then the column matrix has n rows and one column. And so the thing that we're checking for is these inner dimensions always have to be the same. Okay, so if you ever are multiplying two things together and those inner dimensions don't match, then the multiplication won't be possible. Now the way a dot product works is you take the first entry from the row and you multiply it by the first entry from the column. So that gives us the first term in our dot product. But then we will take the second entry from the row and the second entry from the column, multiplying them together and adding it to the previous one. And we continue all the way down the line until you get to the final entry in the row and the final entry in the column. So we add all of these up. So when you multiply a row and a column with a dot product, this gives us a constant, a single 1 by 1 matrix, okay? One number, because we add up all the different values. So let's look at our dot product in this example. We have a 1 row, 3 column matrix, and we're multiplying it by a 3 row, 1 column matrix. So our inner dimensions match, so this matrix dot product should work. So now let's see. If we take the first entry from the row and the first entry from the column, we have 2 times negative 5 plus, and then now we move on to the second entry. So the second entry from the row and the second entry from the column. So we have negative 3 times 2 plus, and now we're on the final entry. We have a 0 from the row and a negative 2 from the column. So plus 0 times negative 2. So let's go ahead and multiply and add. We have a negative 10 minus 6 plus 0. And so our final answer is negative 16. Notice that we ended up with a single answer, right? A 1 by 1 matrix, just a constant, just a number. Okay? So now we'll go ahead and extend this idea of the dot product into matrix multiplication. So if we have larger matrices than just 1 by 3 and 3 by 1.